Good morning to you all. My name is Kwofie and presenting on the topic Lean Thinking for Structural Engineers, which was based on a research conducted under the supervision of Professor Pasquire. The management systems of principles, practices and philosophies originally related to the Toyota production system was first applied to eliminate waste whilst ensuring maximum output. The success of the TPS application in manufacturing has inspired many researchers to explore its application in construction. Unlike the manufacturing industry, which has consistent design processes, the architecture, engineering, and construction industries usually execute unique projects with several complexities, and this makes direct application of the lean production principles in the construction setting difficult. Considering these challenges, several studies have carried out to extract the key lean production system principles, which have successfully been applied to both simple and complex projects in the AEC industry, resulting in delivery of better value while stakeholders make real profit. Successively, review of literature exposed several researchers on lean concept implementation in design phase, with emphasis on designers, but little has been discussed with respect to structural design and engineering works. This research consequently posed a question as, what does lean mean to structural engineers? And so to explore understanding of lean structural design for structural engineers to identify new, efficient and innovative ways of working. The research study was based on qualitative research method using systematic literature review, as it provides guidance for a systematic, comprehensive, explicit and reproducible literature review. In producing the systematic literature review, Denier and Tramfield reviewed and proposed 5 principal steps, which are research question formulation, location of study sources, study selection and evaluation, analysis and synthesis of data, results discussion and reporting. The study therefore was conducted using these steps in conjunction with appropriate methods, tools, and procedures as summarized in the figure shown. Lean thinking concepts for structural design. From the systematic literature review, majority of the publications focused on lean design with associated themes, illustrating that significant emphasis has been laid on lean design concepts, whilst pointing out gaps and solutions for improvement in the AEC industry. In relation to understanding lean structural design, the study qualitatively synthesized 2 key themes, which are lean definitions and lean concept comprehension, as shown in this figure. Lean in the general worldview has been perceived as lacking or deficient in flesh, lacking richness, sufficiency or productiveness, containing little or no fat, deficient in an essential quality. Nonetheless, lean applied to construction has been defined differently by several researchers. For instance, lean production is defined as a philosophy that ensures elimination of waste from a product value stream by optimizing all resources needed for production, according to Womack et al. And others. Lean production was also defined by Sa and Ward in 2007 as an integrated socio-technical system aimed at reduction of waste through concurrently minimizing supplies, customer and internal variability. Hopp and Sperman in 2004 further addressed lean production as generation of goods or services where buffering costs due to excess lead times, inventories or capacity are minimized. The concept of value generation and waste reduction appear to be the spine connecting these diverse definitions of lean when applied to the manufacturing and construction industries. The effect of lean concept have motivated many organizations to adapt it. In the attempt of organizations implementing lean concept, Chase in 2001 observed partial adoption of these lean principles without embracing the underlying philosophy and culture initiated by Toyota. Furthermore, the implementation of tools and techniques have been the major focus of most Western companies as compared to the Japanese approach to lean through philosophy and culture. An overview of research works on lean applied to design demonstrated lean to be a multidimensional concept characterized by different levels and therefore defies a universal definition. However, several researchers have identified lean concepts to be mainly founded on the philosophy and culture with a set of principles, practices, processes, techniques, and tools for customer value creation and waste reduction. Definition of lean structural design. In the construction industry, lean applied to product development achieves the design management field of work, and that's called lean design when applied to building projects. Lean design is an extension of lean thinking in the design phase, which create the potential for high value in the whole process with well-defined systems, structures, and materials to meet customer needs. Lean design therefore relates to the principles, methods, techniques, practices, and tools contemporarily used in managing designs or product development process to generate value for customers. Subsequently, the application of lean thinking concept in structural design can be achieved through lean principles, techniques, processes, practices, and tools to deliver value for the customer. Lean principles applicable to lean structural design. Kwofie in 1992 postulated a new production philosophy based on the Toyota production system principles and recommended its adoption to construction for identification and elimination of waste activities. Further studies by Walmark and Jones in 1996 to implement lean in manufacturing proposed 5 lean thinking principles, which are value stream, flow, pool, and perfection principles. Kwofie in the year 2000 proposed theory of production founded on transformation, flow, and value principles, acknowledged as TFV model, where transformational views of work done is combined with workflow and value delivery. The 5 principles of lean thinking and TFV theory of production have become the fundamental framework for lean application in all phases of construction projects. Lean techniques and methods applicable to lean structural design. Several techniques and methods exist when it comes to lean application, but the 3 key ones identified from literature are target value design, set-based design, and choosing by advantage. Target value design is a management method for designing and delivering customer value aligned with defined target. Based on the following principles of TVD postulated by Makumba in 2007 and benchmarks by Tommelein and Ballard in 2016, structural engineers can collaboratively work with other team members to implement TVD as follows: detailed engagement with customers to evaluate and validate business case and establish target value, collaboratively plan the project with customers, design to meet the defined targets, design and detail in sequence of the customer who will use it, that is the pull system, collaboratively implement learning and innovation in design, review and reflect throughout the design process. Set-based design are characterized by exploration of multiple design options, delays to specifications and commitment, development of extensive prototyping or simulation, and convergence upon the optimum design. SPD can be achieved under these principles: mapping the design space by identification of alternatives to carry forward, integrating and determining solutions from intersections of intervals, and establishing feasibility by maintaining consistency with pre-existing design before committing to a design solution. A critical overview of SBD reveals its incapacity to provide detailed guidance on how to select options, and so are jointly applied with CBD, that is choosing by advantage technique. CBD is a technique for consistent good decision making on design options by focusing on the valued advantages, which is followed by actions and subsequently generates an outcome. Lean tools for lean structural design. There exists a number of tools that can be applied by structural engineers in their design. This includes value stream mapping, quality function deployment, design structure metrics, last planner system, and the 5 S's. That's sorting, straightening or set to order, shine, standardize, and sustain. VSM is a lean tool used to capture the present state of value stream with regards to information and material flows, identify opportunities to improve flow whilst ensuring waste reduction, and proposing future states showing plans of development. The QFD is one of the lean tools that facilitates identification of customer needs and requirements at the design phase. The DSM is a systematic tool for finding the optimal order, originally developed by Stewart in 1981 and applied to represent design information flows such that design tasks are outlined and their interdependencies are assessed to show tasks to be completed both in series and in parallel. The last planner system is also a lean tool originally designed to facilitate stabilization of production workflow, where decisions and commitment to tasks are made by the last responsible person, known as the last planner. The 5Ss is also a systematic process tool used in organizing a workplace such that it contains only the materials needed and appropriately designated, resulting in work efficiency, reduced waste, optimum value, and productivity. Conclusions. This paper focused on the first part of the study where understanding of Lean was gained with respect to structural designs. The research revealed that Lean structural design involved the application of Lean thinking concepts in structural designs through Lean principles, techniques, processes, practices, and tools to deliver value for customers. This research was mainly based on literature and the practical applicability of the findings to assess the understanding and implementation of Lean from structural engineer point of view form part of the second phase of the study. Therefore, further research will be carried out focusing on the relationship between structural engineers and Lean using case studies. Further studies will also be done to discuss possible hindrances to Lean structural design and corresponding solutions. Thank you for your audience.